let's have a look at absolute value functions. Again, we've seen a bit about this already. Y is equal to the absolute value of function x. Symmetry in the x-axis. Okay? In other words, whatever is below gets reflected above, because we can't end up with a positive y, a negative y value. Y is always going to equal the absolute value of something. So if the original graph is below, it gets reflected above. So here's random graph. Everything below, reflected above. Goodbye. See, gone, below, whoop, above. There's our graph. Y equals the absolute value of function x. Okay, function, absolute value of x. Now what we're saying is we can only substitute in positive numbers. We never substitute in a negative number. So this will now reflect in the y-axis, but not reflect everything. It's only going to reflect the positive values. Right? So it'll become symmetric in the y-axis. So what we basically do is, where x was positive, that we're going to reflect over the axis. Here it is. So there's the original graph. I will never be able to substitute in a negative number. All gone. When I now substitute in a negative number, I end up with the corresponding positive answer. And that's why it then reflects over in the y-axis. Because when I sub in, say, -1, I'll go, oh, actually I'm substituting in the absolute value of -1, so I get the same answer as +1. And every single number does the same thing. All right, absolute value of y is equal to function x. So now, what happens? This is also symmetry in the x-axis, but reflect the part of the function where the function is positive. Let's draw it. There's the original. That bit disappears, but now we reflect it. Because now y can be negative. Because we're saying the absolute value of y is equal to function x. So when we substitute x in, not only do we get an answer of, say, +10, we'll also get -10. Because its absolute value of y is the answer. Right, because the bottom half is what we get when the function value is negative. The function value can never be negative. It's always got to be positive. All right, let's try this one. Absolute value of y is equal to the function absolute value of x. Symmetry in both of the axes. So, watch it carefully, we'll reflect the part that's in the first quadrant only, and it's going to go into all 4 quadrants. Because I can only substitute in positive numbers, so I can only use those x values, and my answers have to be positive, so I can only get the answers in the first quadrant. But it'll get reflected into all 4. Right? Well, there's the original graph. There's the piece that I want. But because I can have absolute value of y equals that, then I would reflect that way. But I can also have y equals function absolute value of x, so I also reflect that way. So it's like combining the two ideas. So something like that. Okay, the absolute value of function absolute value of x. Symmetry in the y-axis, reflection in the x-axis. That part again, where it's positive, because I can only substitute in positive numbers because I've got function absolute value of x. But the answers now have to always be positive because y is equal to the absolute value of that. So I can never get a negative answer for y here. So there's the original one. Because watch up the top, that was telling you how we go. Y equals function x. That's function absolute value of x. But then we're saying we want the absolute value of that. So then we get that. Okay. Absolute value of y is equal to the absolute value of function x. Symmetry in the x-axis, reflection in the x-axis. Okay. So this time we reflect the part where it's less than 0 in the x-axis and then reflect the result in the x-axis. Let's have a look at it. There's the original. That would be the absolute value of function x. Which one are we doing now? I've forgotten already. Okay, so what did we do when we said absolute value of y was equal to something? Bingo. How cool is that one? All right, let's have a bit of a play with that.